Hello everyone and welcome back to yet another tutorial. So last time we have managed to modify our softmax function uh, you know with tensor operations, and now we are going to embed this thing to our existing code, and let's see how our Autograd computational graph works. So let me just quickly see the function that we wrote last night. So this was our function tensor softmax, and here I have uh, I have written this function. So what it does basically is it takes the rows of x, right, x tensor, it takes the columns, it takes the dimension, and it creates an output shape, right, on heap. The first index is going to be rows, the second index is going to be columns, and then it creates an actual tensors which we are supposed to return with some empty values for now, and then we'll go on and populate this tensor with our logic of how this softmax works. So let's just quickly create the computational graph, wide up things. If x requires grad, obviously out requires grads, number of parents are 1, and define space for tensor pointer parents. And on the first index we have x as a parent, and then we have operations defined over here, allocated, and then operation backward is tensor softmax backward, which will return on back propagation. And then we have out operations equals to op assigned over here, and then we have grad, which is actually random values of gradient tensor, rows times cons times size of float, right? So softmax is basically each component at softmax at tensor, each component of the tensor, each element of the tensor divided by sum across that row in which it lies in, right? So this is actually the definition. Then we took the exponent tensor exponent method. It takes the arena, allocates the output tensor, takes x, goes rows wise and column wise, take each element and take the exponent of it. Then we have row sum defined over here. This is an important function. Let me just tell you, row sum. Okay, so it takes arena, and here's the computational graph of it, and then here's the logic. So it grabs the row pointer, and it just takes the sum and populates the output. And what else we have? Yeah, so all right, so this is actually row sum. We got the exponent of every element that is inside our tensor. We got the row sum, and then all we have to do is obviously divide these. Before that, we need to expand the columns, because this particular thing returns us only number of rows uh, cross 1 for a shape, because it shrinks down the column dimension, and we need to expand the columns. We wrote our existing function which expands the columns, and then we divide the tensor. So one thing that I wanted to make sure was, in this softmax function, this should not be like columns. Yeah, output is columns, but this should be only one column, right? We need to change this function. We need to change this function, right? So how we need to change this, because why we need to change it? We need to change it because we are already expanding our columns inside this tensor row sum function, which we should not do. We need to find out only rows times 1 for a column from this matrix, from this tensor method, and then we'll use expand column, which we have already written to expand the columns, right? So let me just quickly go ahead and make the required changes. So this is going to be 1, and for now let's comment this out. All right, so we have rows, we have out shape columns equals 1, and dimension equals 2, only one parent. So far it's good, so far it's good. And then um, okay, no, I think I need to make changes here. Tensor row sum, there it is. So yeah, uh, yeah, it's good, it looks good. So are you doing the right thing? So tensor Softmax. Yeah, we've already expanded the columns. Uh, and let's just correct this thing as well. So, or have we? Let me just check again. So tensor row sums gives us columns. We should not receive columns. Yeah, int columns equals 1. Okay, fine, fine, fine. Yeah, so we already defined columns as 1. And then we have tensor softmax, which is right here. And uh, let's just change this to, okay, that's one way of undoing the changes. And yeah, so yeah, this was working fine last night, right? This function was working fine. In case we just run it and see again. Vim run. Okay, looks good. So yeah, we can see the tensor created, and one thing that I want to change over here is softmax. Yeah, okay. Expand columns. So expanded columns, and then we divided. Okay, fine. Let's go to the main file and see if our loop works fine. The forward pass loop works fine. So what we can do here is let's just run it. Boom. Some issue, some problem. Incompatible pointer type. Tensor Softmax need to make all the changes here. Change into Softmax. This should take arena. Softmax. It's gonna take Softmax forward is nothing. It already takes arena. Yeah, this looks good. This looks good. This looks good. Tensor add should take arena. Add in place. We'll see this later. What this add in place does, basically it does not add two tensors. We need to see whether we need to build the computation graph for this or not. So this is our forward or backward pass. Yeah. Slowly and gradually we are might move forward is nothing. Uh, move forward. Yeah, it's nothing basically. Let's go to the 18. Yeah, so let's just delete them all. Forward. Scale dot product attention. What's wrong here? Random, we'll calculate this later. Expected expression before arena. Really? What's wrong here? What's wrong here? Oh, what is this? $279 Tensor Softmax. Okay. Edge. What is this? Declared here. Tensor Softmax. Okay. Let's see the actual errors. Okay, so expected scaled dot product. Okay. Scaled dot product attention. What's happening over here? We need to change this as well. Yeah, tensor transpose QKT matimal. And what's happening over here? I think we need to change this as well. So 1 Q shape 1 plus J divided by square root of dk. Okay, so I think we need to replace it as well. We need to replace this thing as well with what it does. Basically, it's a tensor division operation. So we can say QKT div is equals to tensor. Wait a second. Square root of dk. I think it should be some sort of tensor div operation. Tensor square root and then tensor div, because you see this is getting divided by this thing. This is square root operation and a square root on width tensor. This is actually not a tensor. This is actually a dk, and dk is head dimension. So we need to first create a matrix with dk. Okay, let me just quickly, I don't know if this approach is right or not, but let's just try. Tensor fill zeros. Okay, so yeah, fill zeros, and let's see. No, not void. This should be tensor fill value arena tensor x float v, and like so. uh, out. Okay, turns out TensorFlow val. TensorFlow values dk. Dk shape will be like this, I guess. I think these have shape should equal. Oh, wait a second. So, okay, new random tensor. Let's just create new random tensor. Dkk, let's say, and is equals to tensor. Create new. It's gonna take arena. I think it should be in dkk equals, let's say, v shape 0. Grab any of those. Dkk shape would be what? And now let's fill these. So dkk, well, uh, integer dk. Hmm. Can we like uh, can we do like this? QKT. Okay, let's just do it now. So arena, what it takes, arena, and I think QKT, and then we have DKK SQRT. And why don't we just go ahead and make the shape equals this? So we don't have issue with the dimensions actually, because it's getting divided by the numerator is QKT and the denominator is like DK tensor. So let's just make the shapes equal. Let's just not risk like making it shape equals V instead of QKT. So arena along DKK, everything's fine. Okay, fine. And then we have DKK tensor here, and then we have DKK division and what QKT. Okay, now div QKT soft versus V. Yeah, fine. Okay, we made lots of different changes, and let's see what happens. Tensor fill like implicit declaration. Okay, we don't have anything here. Okay. takes the float, but we are passing integer. This will be an issue. So I think let's just fine. Expected expression before. $280. Ooh. Softmax. What does it take? What's an issue over here? Okay, so tensor QKT, tensor softmax, arena, and DKK div. What is this? Oh, fill val takes integer, yes, that's right. And if we look here, tensor.h fill val, what it takes integer, yeah, that's fine. And should it be like double or what? Multiple declaration of main. Multiple definition of main. Still. Undefined reference to layer norm backward. Okay, so let's just see if our for pass is working because we haven't implemented our back propagation till now, and it should not work as well. So let's see if our for pass is working, and let's go step by step. So we were here layer norm, and then initialize parameters for FFN, feed forward neural network, and everything is fine till here. And inside here we have layer norm forward, and then FFN forward, and then okay, let's just see if it's printing something. So I think uh, printf shape um, tensor shape 2D. Undefined reference ReLU forward. ReLU forward should also be a tensor. Okay, let's just see if our layer norm till layer norm if our model is working. Main C and okay, so where's FFN Ellen? FFN Ellen. Okay. Uh, let's just see till here. Undefined reference ReLU forward. ReLU forward. Hmm. Where exactly is this function defined? Where is ReLU forward? Grab dash R. Okay, so we have defined it. Are you serious? Where does this method go, man? Where did this function go? Let's check in the on GitHub repo if we can find it. So GitHub dot crash. Okay, so where man, I find it funny, really. Like, where did this method go? We have implemented this. Everything was working fine before Autograd thing, and our value is just nowhere. It's no more on planet Earth. All right, so FFNC. Let's just search it together. So if you see here, value. Mm, okay, value backward. There's no such thing called value forward. Okay. So do we have value backward? Tensor feed forward, value forward, and value backward, nothing. Uh, value. Oh man, Where did this function go? I can't understand this. I mean, our function is no more here. So let's just say I think I need to bring this code to VS Code now, because it's getting hard for me to handle all these files inside Vim terminal. And okay, so let's see. So we have something called ffn.c, right? And it should have a ReLU function, ReLU backward. And where is this function, ReLU backward? ReLU backward. Okay, so we've defined it somewhere inside tensor. Okay. Tensor C, yeah, there it is. ReLU backward. Yeah, we do have ReLU backward. Tensor H, ReLU backward. Yes, it's there. It's there. So what is the problem then? Why complaints ffn forward? So undefined reference to ReLU backward. Uh, ReLU backward. Main. Do we have tensor over here? Yes, we have tensor. And it says ReLU forward. Where are we exactly using this? ReLU forward is inside. Okay, fine. So ReLU forward. Uh, ReLU forward is gonna take only one tensor. Should take arena as well, man. We need to change this function. Alright, so I think enough for this video. The videos already went very long. In next video, I'll be actually tracing back this ReLU forward. We've made some changes for forward and backward, forward and reverse paths, so that's why things are a little mixed up, but no major thing, no major issues. We need to check our tensor softmax function if it's working fine, and then we need to check for ReLU forward and backward. If everything's working fine, then I think our forward paths will be working fine soon, inshallah, and then we'll be working on backward. So let me just push the changes. Mm, what did I do here? So, modified tensor softmax. Fine, ReLU and ReLU backward. All right. All right. See you then.